Okay, so the lesson objective, we're going to be talking about relations and functions today. So first of all, a relation is a set of ordered pairs. Oops. A set of ordered pairs. And so we use x and y coordinates to do that. A function is a special kind of relation. It's a relation where each input gives only one output. Each input gives only one output. So when we talk about domain, we're talking about our x values for the input. And then when we're talking about range, we're talking about the y values or the output. So we have three different ways that we can represent a relation. We can use a table, we can use a graph, or we can use what's called a mapping. So I've got a relation here. It's just three ordered pairs, 1, 2, 5, 7, and -2, 3. So I can show it as an XY table. So when x is 1, y is 2. When x is 5, y is 7. When x is -2, y is 3. I can also graph the points. So 1, 2 would be right there. 5, 7. 1, 2. Would be up here. And then -2, 3 right here. So you can also just show it as a graph. Since these are individual points, you don't connect them with lines. You just draw the points in this case. And then a mapping is where I have my input, my output, and I draw like little, I don't know, bubbles for them, I guess you'd say. I don't know what they call these things. Anyway, so when 1 is input, my output is 2. If I put in 5, my output is 7. If I put in -2, my output is 3. Okay, so those are the three ways that you can do it. You can have a table, a graph, or a mapping. Okay, do you guys remember what we call this point right here in the center of our graph?
Origin.
It's the origin, yes. So. All right, and then of course, this is my x-axis and that's my y-axis. Okay. All right, so when we're talking about domain and range, if they give you a graph and they want to know the domain and the range, what you can do is you can draw lines to the axes. So for a graph, we're going to draw lines to the axes. Okay, so domain is dealing with my x values. So if I draw a line from one end of the graph down to my x-axis and a line from the other end of the graph, then I can kind of think of this like a number line. I've got a closed circle here and I've got a closed circle here, and it's all the values in between, right? So you guys remember those from inequalities. So my domain means that x is between 1 and 5 inclusive. So 1 is less than or equal to x, which is less than or equal to 5. That's how I would represent the domain of this graph. And then I'm going to do the same thing on the y-axis to figure out the range. So I go from one end to the y-axis and from the other end to the y-axis. And on this side then, I still have closed points. And I would fill it in between. So if I show that as an inequality, basically y is between 3 and 4. So 3 is less than or equal to 4, which is less than or, y, excuse me, which is less than or equal to 4. So that would be your range. Okay, if they give you a mapping, then it's really easy. You just have your input and your output. So your domain is the input. So 1, 2, 5, and 6 are the numbers that are on the domain. And then the output is -4, -1, and 0. Any questions? Yes. Y is what? Six gives an output of -1. Yeah. Okay. All right, so I'm going to have you guys graph a relation on your whiteboards. Okay, so the relation is the points 1, 3, 2, 4, and 3, 5. So graph that and then show me your whiteboard answer. Okay, so most of you had it right. 1, 3 would be here, 2, 4, and 3, 5. So in this case, it's not a line. It's just those 3 points, so you shouldn't connect it with a line. Okay, so here's another one where you need to find the domain and the range. So I would like you guys to just try this one in your notes on your own. So try to figure this one out on your own, and then we'll go over it. All right, so what you're doing is your domain is you're saying basically how far from the left to the right am I going? So the furthest over to the left is this point here. And so, that blue. So that's at -5, right? So that's where we're starting. -5 is less than or equal to x, which is less than or equal to, okay, well how far does it go the other way? It goes over to 3. So that's your domain. And then you do the same thing with the range, only looking at the y-axis. What's the lowest y number is right on this line here at -2. And then the highest it goes is just a +1. So the range is between -2 and 1, inclusive. All right, so moving on to the next example. All right, so we are going to give the domain and range of a function, and we're going to say whether or not, domain and range of the relation, we're going to say whether or not it's a function. All right, so the domain is just the x values. So we've got 3, 5, 4, and then 3 again. Do I need to write 3 twice? No. So I'll just write 3, 4, 5. And then for my range, I have -2, -1, 0, and 1. So if you look at it, I notice that one of my inputs repeats. I've got the 3 repeating. In order for it to be a function, that means I have to get the same thing out every time I put in a 3. Well, did I get the same thing when I put in the 3? No, one time I got a -2 and the other time I got a 1. So therefore it is not a function because we have 2 outputs for 3. So it's not a function. Okay. All right, then looking at the mapping, I've got an input of -4, -8, 4, and 5. That's my domain. And I have an output of 1 and 2. That's my range. So for each of my inputs, do I get only one answer in the output? Yes, I do. It's okay if I put in a -4 and a -8 and they both give me a 2. It's okay to have duplicates in the output. You just can't have duplicates in the input unless they come out the same. So this one is a function. Okay, it's okay to have duplicates in the output. All right, so on your whiteboards, I'm going to give you a relation, and I'm going to have you tell me the domain and range, and then tell me whether or not it's a function. So let me finish drawing it first. Okay, so give me your domain and your range. Okay, so the domain was 7, 9, 12, and 15. The range was -7, -1, and 0. It is not a function because if you look at the 7 on the input, 7 is giving me two outputs. It's giving me the -7 and giving me a 0. Therefore, it is not a function. All right, the vertical line test. Vertical line test is a way we can tell whether a graph is a function or not. So, for instance, suppose I have a parabola. I can take that vertical line and I can move across it. Does it ever touch it more than one time? No, it doesn't. And so that means if it crosses only one time, that means it is a function. Two or more times, it's not a function. That's right. Okay, so yeah, supposing I have a graph like this, I can see that it's crossing it 2 times, and so that means it's not a function. Okay, graphing an equation. All right, so we're going to start graphing. So to do that, we're going to be using tables to begin with. So step 1 is you're going to choose several values for x and plug them into the equation to find y. Choose several values of x and plug them in. Plug them into the equation. And find y. Okay, and you want to use both positive and negative numbers, and you want to plot enough points till you can see a pattern. So for my example, I've got y equals -3x plus 2. So first I'm going to put in a -2, I'm going to put in a -1, a 0, a 1, and a 2. So if I plug in -2, that means I'm doing -3 times -2 plus 2. And so that gives me 6 plus 2, which is 8, right? So if my x value is -2, then my y value is 8. And so I can graph that. -2, +8 would be right there on the graph. Then if I plug in a -1, I have -3 times -1, which is +3 plus 2. So 3 plus 2 is 5. So my point over here, if I put in a -1, I get a 5. Okay, and you're going to want to be really careful with your negatives, or else it's going to mess up your graph. All right, you guys plug in 0, 1, and 2 and find the other values. Plug in 0, 1, and 2 and find the other 3 points. And then go ahead and plot them. Okay, so for the rest of the points, you should have gotten 0, 2, 1, -1, and 2, -4. And you plot them, it looks like that. And then at that point, you can just draw yourself a line that goes through the points. Okay, this one isn't individual points, this is a line, and so it includes all the points on that line. Okay, now we're going to look at one that's the absolute value of x plus 2 Actually, I think we're going to go ahead and stop here because the bell's about to ring, so we'll come back to this tomorrow.